Hello everyone and welcome to video lecture 4 on interactivity. This is really where we start to push into the bounds of what is truly possible when you use a game engine software. We'll start with some important stuff like using nanite to make sure things don't slow down too much. We'll look at adding collisions so we don't fall through the floor. We'll look at procedural growth so that things only start to appear in the distance as we get closer to it. That way we're not rendering stuff until it needs to be there. Really cool. Also means that we can have an open world that people can keep exploring forever and forever. Pretty fun. Then we'll have a look at some level interactivity. I've got a fun one where we can teleport from one part of our model to the next part of the model by using levels. Then we'll get to the one everyone is looking forward to, making objects move in space. Now they could be always moving, so say a plane going over in the sky or boats moving in the water, or it could be things that move as we get within a certain proximity to that. Really fun, really cool. Then we'll look at audio interactivity so that sounds are playing in three-dimensional space, which means only when we get within a certain proximity can we start to hear it. If we walk further away, it'll get quieter again. If we keep going closer, it'll get louder. Or as objects are moving in space, the sound actually continues on with that object. And then we'll wrap it up with a chat about some of the more complex interactivity you might want to add with plugins like Niagara, where we can create a crowd, where we can create an ocean, where we can play with particles crashing and smashing and all sorts of fun stuff together. Lots and lots to enjoy in this video. Let's get stuck in. Alright, so one of the exciting things you will have seen in Unreal Engine 5 is nanite. Now, a lot of our assets and things that we're bringing in from Megascans are nanite enabled, and with the latest releases, we've also got nanite trees, which is very exciting. Reduces the amount of computing power we need to get all of those polys in, so we get really good looking models without having to do as much computing power. I'm not going to get into the science of it. I'm still only just understanding it myself. But the good thing to know is we can also convert all of our model into nanite as well, so that we can use even less computing power to generate all of this spatial, architectural, beautiful stuff that we've got here. So very easy to do. What we're going to do is we're going to go and find all of the static meshes for the architecture that we've brought through, and we're going to convert them all to nanite. So come on down to our content browser. We're going to filter by static mesh. Then what we're going to do is we're going to grab all of the stuff that has on in front of it from Rhino. You'll recognize the other stuff that's already part of the template that we don't need to grab. That's fine. And we're going to go all the way down because most of this stuff we've added in. Come back up a little bit. Right, and I'm just looking for the last on. There we go. Hold down shift, click that. That's got all of them. Then right click. We're going to go up to nanite. And we're going to go enable nanite for selected. And what that's going to do is you'll see it working away, doing its business down in the bottom right hand corner here. And it's going to make a nanite version. We're just going to convert all of the mesh faces into nanite, which will make things run a little bit quicker. While it's doing that, as you can see there, it also needs to reinterpolate all of the mesh cards, aka all of the materials need to be put in for the new nanite faces. So it may take a little while. I haven't got that many materials on here at the moment in this particular model, and I haven't done that much development to this particular model. So if you're enabling nanite a little bit further down the pipeline, it may take a little bit longer than what I'm doing here on screen. And I'll go ahead and zoom through this now. And once your nanite is finished, make sure you save that. You'll notice all these little asterisks on your static meshes. We just need to do a save all to make sure they all get saved in. It'll take a little bit longer than a usual save to do this, because when you think about it, when we're normally saving, we're just saving any updates to the model, not the whole model. You've done a lot of different updates to this because each static mesh has been converted to something. So effectively the entire Rhino model or whatever software you're using has been updated, and so it'll take a little while to save. And now that nanite's in, I'm just rebuilding my GPU light mask to make sure all of the lighting is working effectively. Alright, so that is my nanite process all done. What I'm going to do now is I'm going to change from lit mode into our nanite visualization so that I can make sure that it has worked properly. So we go down to nanite visualization and then onto triangles. Perfect. So we can see everything that we have here is now showing as nanite triangles. If it didn't work, it'll all show as black. For example, the sky in the background is not nanite, so that's showing as black. I didn't make any of these characters into nanite, so they're all showing as black as well. But all of the architecture, everything that I brought in from Rhino, all of our static meshes are now using nanite, which is great. Believe it or not, all of this crazy colorfulness is going to make things run a whole lot faster and more efficient for us. And we can go ahead and change this back to lit. All right, now we're going to look at collisions. Collisions are what allow us to move around through the space, to be able to stand on a floor without sinking through it, to stop ourselves from running into objects or walking through objects and killing that realism. So let's take a look at an example now. So if I right click and play from here, give that a second. Here we are. I'm inside my game and I'm now walking around inside this, and I can see I'm walking over the top of this particular slab, which is fine. However, if I am to step down into this pool, we'll see that I start to float through space forever and ever until I stand on something else that has a collision, which in this case is the landscape that we made before. So what we need to do is set up some collisions for the rest of our model. Let's go ahead and do that now. Press escape to get out of the game. And as usual, I use my cameras to jump back to where I want to be. All right, so we need to set up some collisions. What we'll do is we'll do one together so that we can see how it works. And then we'll look at doing a whole bunch at the same time. So I've clicked on this floor over here, and let's move over there as well so we can see what we're doing. So I want to make this floor have a collision running all the way around it so that I can stand on top of it without sinking all the way through it. So first things first is we're going to click the floor, double click on its static mesh down here, and then we're going to go up to collision, and we're going to go to auto convex collision. So there's simplified ones over here, but I find what they do is they just add usually a big cube around it, and that doesn't necessarily work for our architecture, which is different shapes. So auto convex collision, I'm going to click on that one, click on apply, then click on save, and then we can jump back out of there. And then what we're going to do is we'll hit Alt C on the keyboard, and we should be able to see that it has wrapped the collisions around it, which we can. So we can see we've got this box, that's the edge of the box out there, and the box is going to slope downhill, which is what we wanted. We wanted it to go down into the pool. We didn't want it to just shear off at the edge, and we didn't want an arbitrary cube shape. We want it to follow that angle that it's going down in there. So that looks like it is working. If Alt C is not working for you, remember you can just come up to Show and Collision. We'll go ahead and turn that off now. So let's test that. What we'll do is we'll just start our game from here, right click, play from here. Here we go, we're in our game and I'm not falling through the floor, so we know that it is working. Excellent. Press escape to get out of that one. Right, now I want to show you a slightly different version of the collision we can add. So I've gone ahead and I've added a collision to this vault that we have here, and we can see that the collisions are in place, but it's a little bit clunky with how it comes together. It's not completely going around the geometry, and it's not exactly vacuum sealed to the geometry. Now it'll work. In most cases this will work. It'll stop us from bumping into this, and that'll be fine. But there will be some parts of your model that have a little bit more detail than this, where you'll need it to sit closer to the actual geometry so that you can walk past it or walk through it. Particularly if you've got a small opening or something like that and the collisions are just coming too close together, there is a way to have a more advanced version of the collisions. So what we'll do is we'll click on the one behind this, the second vault over there, static mesh, similar process, except this time we're going to go into the details tab, type in collisions, and then we're going to change the collision complexity over here from the project default to the use complex collisions as simple. Click on that one, click apply, click save, give that a second, and then what we'll see is we now have our collisions wrapped tight to this one over here. We can see that it's following all the way along the geometry, it's following the architecture 100%. It's taking the curves, it's taking the point up the very top, it's taking very, very close to the actual geometry itself for the collisions. Now this you can do for probably something as simple as this vault that I have here. You can do for your walls, you can do for your floors, you can do for your big stuff. Where you want to be careful, unless it's absolutely necessary because your collisions are getting too close together and you can't actually walk through it, you want to be careful doing it on things that have too many different faces to them. So for example, a big rock that you've got from Quixel Mega Scans with a bunch of nanite faces on their mesh cards. this would get really complex really quick, and your computer has to work all of that stuff out in the background just for you to be able to walk around it. Use these methods with balance. So for example, if I need to be able to weave through these different vaults that we've got here, I'm definitely going to need to use the second method, because everything's going to need to be tight to the structure so it'll actually fit around it. If it's a big hole like this, or a big opening, or it's a really complex geometry like a nanite rock or something like that, then use the automatic version. Alright, so how do we do a whole bunch of these at the same time so that we don't have to click on them one by one? Let's go back to our static meshes once again. So we're going to go by static mesh. We're going to select all of our static meshes, much like we did when we applied it with nanite. We just go through here. I'm actually going to come back in here and hit Alt-C again just to turn off that show collisions for the moment, because it's slowing everything down for me a lot while I'm doing some editing. I'll turn it back on when we get there. So grab that mesh, back up to the top, shift, right click, asset actions, and then we're going to bulk edit via property matrix, this one here. Now if you're like me and you've got a lot of different assets in there, a lot of different static meshes, this might take a little bit of time to load, so I'll zoom through that. Alright, again, select them all. So grab the top one down to the bottom one holding shift, grab them all, then we're going to go in the property editing up here, type in COL for collisions, and then we're going to hit use complex collision as simple. Click on that. Again, that might take a little bit of time to update. Give it a second. Great. And then we're going to do a file save all. That's going to take a little bit of time, so pour yourself another cup of tea. Beautiful. All saved. We can close out of that one now. And here we are. I'm going to step back a bit and let's try and have a look at our collisions. Hit Alt-C. Okay, so our collisions are wrapping all the way around our model now. We should be able to see everything. All of our static meshes all have collisions wrapped around them. Perfect. Let's go ahead and turn that back off. And then what I'm going to do is play from here. Right click, play from here. Give that a second. Let's go ahead and do a little walk around and see how we go. All right. So I can't walk into the arches, which is good. I can't walk into the wall. Perfect. I can walk through the arches, our vaults. I can walk around this character, excuse me. What else have we got? Can I go on the water? I can jump around. Can I jump through into a vault? No, perfect. What about my water edge? Great, okay. Perfect. I didn't want to be able to sink all the way through into there. I can look at lowering that collision down a little bit later, but for now, I'm perfectly happy with having all of these collisions in place, so I can actually walk around inside my model. Perfect. Collisions are working very successfully. It's not slowing down too much either, so I'm pretty happy with that for now. Alright, great. So that is our collisions working nicely. We can navigate around the model very well. It's moving pretty quickly as well, which is good to see. Now you may notice something here in this model that we're actually quite a bit taller than some of the characters in the space, and you might be sitting a little higher than you want to in your model. And you'll also notice if we have a look at our reflections, we get a little bit of a glimpse of it over there, but our actual character is just a set of arms. We don't actually have a body yet. So what we can do, there we are, there's my arms. What we can do is we can go ahead and make some edits to the character itself so that we can not only set the height of the character, but we can also make sure that if we do happen to pass any reflections, it's not just going to be a bunch of arms. Let's have a look. Alright, so the first thing I'm going to do is show you what the problem is. So if we type in first, and then we bring up first person character, and we change over to viewport, we see this is what we're actually looking at. So we've got a camera and a set of arms. So as we're moving around, this is what we see. This shell here, that's our character. The actual static mesh attached to the character is the set of arms, and then the camera obviously is moving around with the arms. So this is why we don't see anything other than a set of arms. So what we need to do is fill in this static mesh asset so that we can have some sort of body that follows us around. Now we can go ahead and bring in this tutorial one here, and that will give us a body. Problem is, this one doesn't have any motion to it, so those arms are just going to stay out. left and right the whole time as we're moving around. And we're going to have the second set of arms on here as well. So there's a couple of ways around this. You can go and download a character from online, something that you want to put into there that's already rigged up and ready to go. But I've got a simple version for us because remember, the character is not actually the priority, the architecture is. So let us have a look at a very quick and simple way of fixing this. So jump back out of here. What I'm going to do is I'm going to click on add, and we're going to go add feature or content pack. And then I'm just going to add the content from the third person because the third person already has a character in it that we can use. So rather than going online, rather than trying to figure out all the rigging and getting the blueprint to work properly for us, we're just going to take what is already as part of the third person, bring it into our project. Bob's your uncle. Let's have a look. Click on add to project. As usual, that will take a little while to load. There we go. And now we've got that third person character inside there. There's our little third person character. And then what we're going to do is go back to our content, type in first person character, back over to viewport. All right. And then we click on the arms and then come over to this drop down over here. You notice we've got a bunch more different characters in now that we've added that. I'm going to go into SKM Quinn. It's a slightly smaller character. And then we're going to change the animation class to ABP Quinn. There we go. That's got our character. And we see there's some motion now in the character as well. And we click back inside the viewport, hit E to toggle on the rotate. And we just want to rotate this around by 90 degrees so that our character, she's looking in the same direction as the camera. Her head height might be a little bit high. We're going to test it first and see how it looks. Sometimes you want the camera to sit in the chest so that we see the arms moving in front of it anyway. So it might be okay. For now, let's click on save, back, and let's go right click, play from here. All right, let's have a look around. Go up to our reflection. Aha, that's us. We have a reflection and we have motion with our body. So now we are not just a set of arms, we are a person and we can see our hands inside. So how are we for height? We're actually pretty good. We're pretty close to our existing character's height and it feels pretty appropriate inside the space as well. We're a little bit taller than this person, but she might just be a shorter person. I think this is pretty good. I'm pretty happy. I like the arm movement as well, where we get a subtle little bit as we're running through the space or as we're jumping around. It's not too much. So I wouldn't go moving the camera any lower. And the camera feels about right in the height of the reflection to the head sitting just above the horizon line there. Yeah, I'm pretty happy with that. So that is our simple character setup. Now, of course, you can look at some YouTube tutorials and figure out how to add your own different characters. If this isn't the type of character you want to see in your reflections, perfectly fine. But importing that third person template and swapping out the arms for a character is certainly the easiest way to get through that. And then you can go ahead and move on to more important parts of your modeling. Right, now we're going to have a look at what's called procedural foliage. So before we showed how you could use a paintbrush to paint in a whole bunch of foliage very quickly. But what if we have more of an open world where we want foliage to automatically create around us wherever we're walking and not be in the distance or not be behind us as we move. So effectively, the foliage is going to move with us so that we can use less computing power as though we're only using a handful of meshes, but we still feel like we're in the middle of a forest or in the middle of a canyon or whatever it might be by using procedural foliage. All right, so the first thing we need to do is go up to edit, editor preferences, and type in PROC for procedural, and then click on this one up here, procedural foliage. We need to turn that on. There we go, and that will just enable us to be able to experiment with procedural foliage. So I've just downloaded a cactus instead of doing a forest. I've got this deserty landscape. Still going to be able to see how procedural foliage works, but I thought it'd be a bit of fun to put some cactuses through here instead. So let's jump back out into here. We're going to do right click, foliage, static mesh foliage. And then I'm going to do this cactus foliage static. There we go. Double click. And we're going to add our cactus mesh up into here. Beautiful. Click save. Done. And now we need to make our foliage spawner. Typically you make this in a separate folder, but just because I've only got the one cactus in here and all of my other foliage, I'm just going to chuck it straight in here. So right click, foliage, and we're going to go to procedural foliage spawner. I'm going to do procedural foliage spawner and cactus. Cool. Double click on that. And this is going to be your randomness. If you remember back to Grasshopper or anything where we had parametrics where we could toggle stuff. So the randomness seed is just going to randomly put it somewhere. You can change the seeds for different geometries, different shapes of their locations. And then these ones under here, you can leave in as default, perfectly fine. We just need to add our foliage types. So we've got cactus FS is our one that we got there. We can add more, obviously. If we want to add some rocks, we want to add other cactuses, want to add other plants in there as well, we can go. For now, let's just do the one so we can see what it's going to look like. Click on save, close out of that. And now what we need to do is create a procedural foliage volume. So we're just going to go up to here, down to all classes and down to P. They're all in alphabetical order. Here we are, procedural foliage volume. Grab that one. Put it in, and then we need to change the scale. Obviously our cactuses are only going to go in there at the moment, so we need to make this significantly bigger. Scale over here while we've got it selected. Let's go with 200. We're going to deselect this one here. We don't need it to be 200 tall. Let's go ahead and just make it 20 tall. Even that is probably too big, but for now that's enough for our space. That's fine. Once we do that, we scroll down to where it has procedural foliage spawner, and we're going to add in our PFS. That's our procedural foliage spawner we made just before. Click on cactus, and then we're going to click on resimulate, and that has filled our landscape in with lovely little cactuses. And then of course if we add different items into here, it's going to add different elements in as well. So for example, if we double click back on our PFS cactus and we add a rock or something else that we've already got ready to go, click on save, go back down here, and we need to resimulate again. So we scroll down, resimulate, and then it has added some rocks in the space as well. So you can add whatever you want to your procedural foliage spawner, and it will fill out that volume for you so that you've got a lot more stuff sitting inside your landscape, and it's nice and randomly placed. Obviously, the wider variety of assets you add inside here, it's going to make it feel more and more random and more realistic. One thing we'll notice if we right click play from here and we start walking around inside our space is we're able to actually walk directly through any of these assets that we made, including these cactuses. Ouch, spiky. Simple fix, just go back into the foliage itself. So we're using cactus and rock 1. So double click on cactus, go down to collision presets, this one here, and we're going to do block all. And then one more step, we're going to go into the actual static mesh itself. And you remember from before, we type in collisions, and we're going to change our collision complexity to use complex collision as simple. Click on save. That would do our cactus. We're going to do the same thing for Mr. Rock because he's in there as well. So collision presets, we change to block all. Then the static mesh itself, same thing again. Up here, collisions, and use complex as simple. Click save. Cool. And then we just need to resimulate this again. So let's go back to our procedural foliage volume, resimulate. Cool. Right click, let's have a go, play from here. Haha, we're getting stopped by our rock. And we cannot walk into our cactus. No spiky spikies for us. Okay, that's good. So now we not only have a random landscape in front of us generated by Unreal Engine, we also can't walk through it, which adds into our interactivity, and I can actually climb on top of my rock here and get up higher. I can jump onto this rock over here. So again, we're embedding more interactivity into this zone now using the power of Unreal Engine. Alright, so for our culling, first thing I'm going to do is increase the size of our box. So we can see if we come up higher, our 100 meters by 100 meters is only going out to that range there. So what I'm going to do is grab my procedural foliage volume, come back down here, and we're going to make this out to 1 kilometer. Okay, so that's going to go out in that direction, in this direction. That's going to get significantly bigger, and then what we're going to have to do is, of course, reload it and then re-simulate it. So we'll come on back down to here, click on re-simulate, give that a second, and we can see it now stretches all the way off into the horizon, which is fantastic. Looking good. And especially if you were in a forest or some other environment where you want it to stretch out for a really long time, this would be perfect for you. And we're in nanite as well, and our LODs are working pretty effectively. It's not changing our frame rate too much. However, if your computer is not handling this as effectively, using cull is really going to help you, because it's only going to create cactuses or create whatever you've added to your foliage as you get closer to it. For example, you might create buildings as foliage, because remember, you can add anything you want to your foliage, so that as you're walking down the street, buildings will assemble themselves in the distance. We can't actually see that while we're walking around playing, but it's going to use a whole lot less computing power if things only appear as we get close enough to them for them to appear. So what we're going to do is go back and find our foliage types. They were in our 3D assets. We've got our cactus. So I'm just going to double click on this one here, and we're going to type in cull. And this maximum distance is how close it can be to us. If it's a 0, it's not doing anything, so it's not changing anything. But as soon as we enter a positive number, it's going to create a radius around us. So for example, if I only put in 1000, we'll see that I've only got a handful of trees. It's only generating trees within a very, very small radius to us. If I up this to 10,000, add another 0, we'll see a much more realistic configuration. So from where I'm standing, particularly if I stand a little bit lower down, I can't actually see the cactuses spawning unless I'm looking out for them. If I look on the horizon out there, we'll see that, yeah, maybe I can see some of the popping of some cactuses spawning, but generally they feel pretty good. They feel pretty realistic. There's some clearings as well as they open up. It's looking pretty good. I'm pretty happy with all of this stuff. So that's fine. Go ahead and save that. We'll try the same thing for the rocks, but I reckon we're going to have a smaller number because we need a lot more rocks in the distance. So rock 1, go up to cull, and then we'll try 10,000 as well. Yeah, so we're losing a lot of our horizon with our rocks. So it feels like we need more rocks in our scene, otherwise it just looks too empty. Now obviously we can come down a little bit lower, but yeah, not really doing what we want. Let's try 50,000 instead. Yeah, that's probably a bit more effective. Might even be too much. We might not even need that. We'll jump back down. We just split the difference there. Go 25,000. Yeah, so that's still filling the horizon line for us. We don't see a gap off in the distance, but at the same time, we're also not seeing rocks spawning as they come. So that is our procedural growth. We're only really creating foliage items as we get closer to them within our procedural growth zone. So we could now make this procedural foliage volume absolutely massive, because it's only going to spawn within a radius of us anyway. So it doesn't matter how big that gets. It's only going to spawn as we need it. So if we were to play from here, and if we run through our game now, we'll see that it's only making rocks and only making cactuses as we go through the game. As we walk through the model, it's only creating stuff as we need it off into the distance for us. And that is going to make things run a whole lot smoother and mean we can get in some pretty interesting detail. Nice interactivity layered in as well, that things are only generating as we need them to. Where you can get creative is we don't just need to add landscape elements into our foliage, because remember, we can add any static mesh we want to. So any object we want, anything we make in Rhino, anything we download from online, we can turn anything into foliage and then set up a procedural foliage volume so that it only spawns as we're walking through the model. As we're interacting with it, engaging with it, things are starting to appear for us, or things are appearing off in the distance, so that we always feel like we're part of that world, and it starts to feel a lot more like an open world rather than just a three-dimensional model. All right, and the last thing we want to do with our procedural growth is have a look at the density itself. So say, for example, we're happy walking through here, we like the rocks, but the cactuses, we want to have a bit more density of that. As we're walking through, we feel, yeah, I don't want to add a different type of cactus, I just want more of these same cactuses here. So we come down to our mesh foliage we've got for our cactus, double click on that. Now let's also open up our procedural foliage volume on the right hand side so we can resimulate when we're ready. If we scroll down inside our cactus foliage, we'll come down to the procedural section. The curve is pretty cool as well, by the way, actually. So the fall off curve, what that's going to do is, say for example, we've got a forest. And when we get to the edge of the forest, we want the trees to start to thin out before we get there. So it feels like we're not just in a thick forest and then out of the thick forest. It starts to get thinner as we get towards the edge. So you can actually create a curve. So it's thickest at this point, and then it's going to start to get thinner and thinner as we get down there. And you can create a really interesting curve on there and then simply just apply that. That's really cool. But if we go just underneath that here to our collision radius, this is going to determine how far apart each cactus is going to need to be. And therefore, the higher number, the less dense this is going to be. We'll bring that down to 50, and we'll bring the shade radius underneath down to 50 as well. And then we'll go ahead and click on save. And then we're going to hit resimulate. And then we have increased our density of our cactuses. So you can think of these numbers as the minimum distance between each of those foliage items. So the smaller the number, the closer things will get together. If you want to push things further apart and have less density, then you simply just increase that number. Click out of that and we can walk on through it, and if we go ahead and look up, we'll see that that is growing at that density. Procedural growth is pushing as we get further and further out, so we're not using up all that computing power to get there. It's creating a nice random pattern. What I like about the procedural growth is we also end up with stuff like this, the clearings. Because of the randomness, we'll have areas where it's really dense and then areas where it opens up. And this is a lot more realistic to what we would have in reality as well. It wouldn't just be perfectly homogeneous the entire way through. It would chop and it would change. We'd have dense bits and really light on bits, just like this as well. That is the beauty of using a procedural foliage volume. Okay, so we're on to the phase now where we're ready to start layering in some interactivity into our model. And of course, because we're using Unreal Engine, a game engine software, there is a whole world of interactivity that we can go out there and find and bring into our model. I want to preface Blueprint and everything we're about to do beyond this point with a reminder that at the end of the day, the architecture is our priority. Interaction is going to be something that we add in to increase the user's experience. But because this is architecture school and not animation or games design school, it is perfectly reasonable for you to take blueprints that you find online, or for you to follow the steps from YouTube tutorials that you find online. Wherever you source your blueprint is perfectly fine. We're not expecting you to be coders. We're not expecting you to do any coding from scratch. So yes, it is highly recommended that you bring code, that you bring blueprints in, or that you follow the steps of somebody else's blueprint for your model rather than trying to start from scratch. Every one of these demonstrations that I'm going to show you, I've learnt myself through YouTube. So there's no expectation for you to do anything differently. Fundamentally, we care most about the architecture. That's what you're going to be graded on. You'll be graded on the experience and how immersive you can make that, but it's the spatial qualities, it's the architecture that we're still prioritizing. So just keep that in mind. You can get your blueprints from anywhere you like. All right, let's have a look at an example. All right, so the first blueprint we want to look at is a pretty straightforward one. It is a level change. So say, for example, we've got a whole bunch of levels. We've got a couple of different options of what we can do. Obviously, we could, if we wanted to get up to the pool space, we could walk around. We could go in through the building underneath the stairwell and then up through the lift. And we could create a pretty interesting blueprint where when we stand on the lift, it takes the character upwards. Maybe we even make the lift core glass so we can see all of the surrounding landscape and we go up, whatever. Another way we could do that is to teleport by going from one level to another level. So what we can do is we can create something like this platform here, or it might be a big dark corridor that once you walk inside the dark corridor, it fades to black and we go somewhere else, whatever it might be. To keep things nice and simple, all I want to do is stand on top of this platform and then I will be teleported up into the pool over there. So we've got those two different levels to play with. So to do that, let's go ahead and make our first blueprint together. So we'll right click on here, blueprint class, and we're going to get an actor blueprint. We're going to call this teleport levels. And this one is going to be D to P, just to remind me that it's desert to pool. Okay, so we double click on this one here, and first thing we're going to do is we're going to add a plane. Then we are going to add a collision. So type in collision, a box collision. And the box collision needs to be just a little bit smaller than the actual plane itself. So what we'll do is we'll make the plane a little bit bigger first. R key to change to your scale function. I'm just going to bring that out a little bit. And that's going to scale both. And yeah, I'm pretty happy with that. Okay, once we've done that, change back over to box, hit compile. And then while box is selected, we're going to come on down to our events. Very similar to if you remember when we were using InDesign for assignment 1 and we wanted to add interactivity to our PDF. It's kind of like an if-then event. So if a character is to stand on top of this plane and intersect with that box, that collision box, something's going to happen. So we want on component begin overlap, i.e. once our character is overlapping with this collision, something's going to happen. So we click on plus, and this is where we determine the something. So I'm going to grab this guy here and just drag it out into the plane and then let go of the mouse. Type in level, and then we're going to go open level by name. So once we collide with that box, we want it to open a new level, and then all we need to do is type in the level name that we have here. So pool level, it is case sensitive, so make sure you're matching it exactly. So I've got pool underscore level, cool, hit compile, hit save, and we're good to go. Now what we need to do is just drag that blueprint into the space. So I've got my little box there, and that is our blueprint, and I'm going to scale it down a little bit. R for our scale translators, just bring that in just to the size of our box that we've got there. And it's overlapping still a little bit. Let's bring it in a little bit more. R to rescale it. So I want it to just sit inside the box itself, because we need to think if we want the person to actually climb onto the box before the event happens. Otherwise, it's a little bit weird that we just kind of stand here near the rocks and then the level change happens anyway. So we want it to be inside the box so that we actually have to get onto the box before anything happens. All right, we're all good with that now, and our first blueprint is ready to be tested. So first things first, we're going to test this by going right click, play from here. And here we are inside our game. Just give that a second to catch up. Yep, it's looking like it's running normal speed. And then I'm going to climb onto my box. And there we go. Level change. And there we are. So we have just transported ourselves from outside over there in the distance. Can't see because our fog is on now. Remember, because we're on a different level, we've got different settings set up here. So our lighting is all already set for this level. So we didn't need to worry about redoing all of those settings for a different spacer inside, because we've already set it up in levels ready to go. And that is how we can jump from level to level very, very quickly. All right, what I want to do now that I'm inside this space is to set up a return. So say for example, I jumped here, but the client wants to be able to jump back out into that space. So you want to be able to go to a previous level rather than walking onwards. Of course, I can walk onwards and go into the next phase, but what about going backwards? So let's set up a backwards level first. All right, so what I'm going to do first to make things a little bit easier for myself is give myself a place to spawn back to. So player start is going to be here. So there we go, that's my player start, and the direction it's pointing, this big blue arrow, is the direction you're going to be facing when you come back in as well. So I'm happy to start there. I'm not putting myself in the middle of a collision zone so I get stuck and can't get out of it. That looks fine. And that's going to be my player start for this level now. And I can go ahead and save that. And then I'm going to do the same thing up on my pool level as well. So double click on pool level, save selected, let that save. All right, here we are back in our pool level, and I've gone ahead and done the same thing in our pool level as well. So I've got a player start on both sides. In the desert level, it's down by where we started before, and on my pool level, I've got one up here. Now what we're going to do is do the reverse of our teleport. So say for example, if we were to jump off of this edge over here, we'd be able to teleport back down to the desert. It's going to be exactly the same process, just in reverse. So I'll zoom through this quickly. Alright, so I've just made that, I've made it the reverse version so I know which one's which. Got it inside this space here. I need it to be a little bit bigger. R. Let's go ahead and pull this out. And it needs to be bigger than this direction too, just in case I jump. I don't want to miss it. W. Cool. Let's come out here. I want to make sure we definitely get that edge. And come down a little bit. Pull off of that plane. So now the idea is if we were to step off of here, we would hit that collision and then we would jump down to our desert level. One thing we might want to do, depending on what experience we're trying to get, is maybe we don't actually want to see the plane. Maybe we want it to feel like we're falling off the edge a little bit. And so we can come back in here and simply just get rid of the plane. Just keep the collision box inside there. Compile. Bring that back, and so now what will happen is it will be effectively invisible. You're not going to see any of this when you're playing the game, but we'll know that it's there. And in that case, what I might do while this guy is selected is just grow this out a little bit so make sure we're covering our bases. Cool. Okay, let's give it a go. Play from here. All right, so yeah, we definitely can't see anything there, which is great. Let's have a go at stepping off the edge. And there we go. Jumping back to our level now. Give it a little bit of time to load. We're back in. And we are in the same location as that player start that we made before. So we know we're in the right spot. Let's try the reverse. Try and jump back up here again. And we're inside our pool in the same position where we put our player start before. And if we want to, we've got that nice continuous loop now. And that is how we add a change of level using our very first blueprint. Now what you might want to do is you don't have to necessarily just step onto things, you can step through things. So for example, what you might like to do is have this vault here. When you actually pass through that vault, maybe it's all black and dark in there and it's a corridor, but as you pass through it, it then transports you to another level as well. So there's plenty of ways to go around it. All we're doing is colliding with some sort of volume that we've set out. So we can have something tall and skinny that we pass through. We can have something flat that we stand on, whatever you like. You can create a change in level from one part of your model to another part, or one teammate's part of the model to a second teammate's part of the model. However you want to do it, you can change from level to level very easily using that same blueprint method. All right, on to our second blueprint now, and this is probably the most common one we'll be looking for, and that is when we get close to something, it moves. Now, it might move towards us, it might move away from us, it might move up, it might move down, it might rotate. All sorts of things will happen when we get near something which involves movement. So this is a pretty straightforward blueprint and one that we're going to see a lot of. So what I want to do is grab this giant mass of stone and drag it upwards so that we're going to be able to enter through a doorway as we approach it. We don't know it's there until we walk around in the space and find the doorway. Now this applies for pretty much anything. We enter a proximity field and some sort of motion happens. Now you can adjust this however you want. We'll have a look at this to create a doorway, but you can move anything. You can move any static object and you can change the settings as well, how it moves, how close you have to get, etc. So I've made a blueprints folder now so that we don't just keep making stuff over the top of any random folders. So same process, new blueprint class, I'm going to make an actor, and then this is going to be our door vertical motion. Cool. Double click on that. And let's move this in. We need to add a static mesh. So type in static mesh, this one here. And then the static mesh we're looking for is the object we just created. So remember, easy way to find something, if you click on it, and then you'll see it over here in the details tab. If you then click on browse to that folder, I can then go and find it. There it is, and I put it onto my static mesh, and there it is ready to go. Next component we're going to add is the collision box. So how close are we going to get to this thing before it starts to do something? So again, type in col box collision. We've got that. Let's step out a little bit so we can see where our box collision is. We can see we need to make that a lot bigger. So let's go ahead and grab this. And we don't want it to go past it in the left and right directions because we want to approach it down that hallway. So we don't want the door going upwards when we're walking in the pool or swimming in the pool, anything like that. So we're just going to make sure that it is in that same direction that we're going to be walking in. Cool, happy with that. Click compile. Same process. When we've got our box selected, we're going to come down here and then we're going to do on component begin overlap, exactly the same as last time. Click on plus. And then this time we're looking for a set relative location. So move this over a little bit, move this guy over. So right click anywhere inside here and we're looking for set relative location. So if you can think about it, what we're trying to do is say, I want to go from here to here. So set the relative location relative to what we're doing. We're doing it with a static mesh. We can pull this over here. Go ahead and delete that static mesh off of that one because we're going to bring our own in. Just drag and drop that in here. And then we're going to plug that in. That's the target. Beautiful. We're going to then connect the event node to our function. Move this down. And then click on compile. And then we just need to change its location. Now I just want mine to move up vertically. So that is the Z direction. Let's go up by 4 meters and we see how that works for us. Click on compile. All right, let's step back a bit and then we'll try it and see if it's working. All right, let's have a look. Huh? Okay, it's not going up enough there. I only went up by a tiny little bit. So let's try and change that number and massage that until we're happy with it. So we'll come back into here. Let's instead try, let's try 50 and compile. And we'll have a look again. Right click, play from here. And let's go forwards. And then we shot up. Cool. Yeah, I'm pretty happy with that height. I don't mind it actually. It was very jumpy though. So we're happy with the height now. We've got a doorway. Let's have a look at how we can fix up the timing of that so it flows a little nicer. And also so that it returns back down. We don't want it to stay open now that we're moving backwards. Of course, we can go ahead and walk through it, but we want it to go back down. So let's go ahead and jump out of the game, press escape. All right, so we'll open our blueprint back up and what we need to do is add a timeline inside here. So we'll move these guys out of the way, right click and type in add timeline. And let's go ahead and we'll open it up, double click to open, and then we're gonna click track. And because we're moving in vector directions, we're just going to add a vector track and we're going in the Z direction only. So we can go ahead and lock our X and Y to make sure they're not going to move and it's only going to happen in our Z direction. And then what we need to change is our timeline. So the length of time is the amount of time it takes to do the motion. So for this door, let's call it a door, to move upwards, how long do we want that to take? I want 2 seconds. 2 seconds is more than enough time. 5 would be ridiculously slow, but of course we can come back in here and edit that. Then what we're going to do is hover over at the start, so over at the 0 second mark with your mouse, right click and go add key to Z, and then we're going to do the same thing over on the end point, so the 2 second mark, right click, add key to Z, then it's going to determine both the time that it takes, so let's bump that all the way out to 2, and then what's the value, how much is it changing by. So we need to pull this all the way out. We determine that to be 50 is the amount we're going to change by. So we just need to zoom out a bit in order to be able to see that. And this little button over here is going to allow us to fit it in vertically so we can see the two. And then obviously if you're playing in the opposite direction, you can zoom that way as well. And that's fine. That allows us to see the full graph now. And then what we're going to do is one final step so that it doesn't start very heavily and then finish very heavily is we're just going to select both of these, holding down shift to select both, right click and then select break. And what you see is it just adds a softness to the curve. So instead of going very, very quickly from the start and then the same speed and then very, very quickly at the end, it's going, I want to slow at the start, pick up speed, and then start to slow down again at the end. And then we click on compile once we're happy with that. And then we can jump on back to the event graph. You could probably close out of the timeline if you want to, doesn't really matter. Let's jump back into here. Then let's just make some space here. I'm just going to move my little static mesh guy out of the way. And then I'm going to plug in my component here, which is the begin, is going to be play, and that is going to start it. But if we were to pull backwards, like we talked about before, if we were to move backwards and we want the door to come back down, we go back over to our collision box here, because remember that's what we're colliding with. So if we're moving away from it, we're stopping the collision with it. We're going to go add event, and then second one down, end overlap, and we can go ahead and pull this one up here, and we can see that this is the opposite. So we're beginning and we're ending. We take this one here and we're going to plug it into reverse. So if we hit the collision box, we're going to play this, and if we go away from the collision box, we're going to reverse it, i.e. our door is going to move upwards when we hit it, and it's going to reverse when we pull away from it. We're then going to override our new location with the track, because this was just jumping it from 0 to 50. This is the new track that we're putting in here, so that goes into the new location. Just think yellow to yellow. Update is going to plug into this one up here, and then we are all set to go. Click on compile, and then let's go and test it. Let's pull back a little bit, right click, play from here, and as we move forward, our door should go upwards. As we move backwards, it should go back down. Perfect. So we can change the timing on that if we want to slow that down. I definitely want to change the proximity of that one though. We have to get too close to it in order for the door to open for my liking. So what I'm going to do is exit out of the game. Then I'm just going to come back to my blueprint, go back over to the viewport, and then we're just going to extend this out a little bit. So this box is our collision, remember, so we have to hit this before the action is going to happen. So all I'm going to do is I'm just going to stretch this out a little bit further, hit compile over here, then let's try that one more time, right click, play from here, let's go, there we go. So now we have to get not quite as close before it starts to open. And of course we can adjust any of those settings. So if we want to have the door move more slowly, we can do that. If we want to have a different static mesh to be in there, we can replace that with anything we want to. If we want to change the texture on that, anything we want, it is all just located inside of these blueprints. So the viewport, that is the actual object itself, and we can change what the static mesh is inside there. We have the box which we're colliding with, so we can change where we need to stand in order for it to happen. Then the event graph tells us what actually happens. So all we've done here is we've said this static mesh that we have here inside this location, it's going to start here and then it's going to end up at a new location. The first bit is when we hit the collision box, this is going to start. When we move away from the collision box, this is where it goes back to where it was. And then all we did here in the timeline is say that 0 to be when it first happens, and then we want 2 seconds to be happening later, and then across that time we want it to change by 50. And then if we want to edit those very, very quickly, we can jump up here. So say for example, I want to push this up to double the height, but take the same amount of time. I can click on compile, jump back into the game, right click, play from here, move forwards, and then we can see it's gone up double the height this time now. So that is how we set up our basic movement blueprint. So again, you can adjust this to anything you want. We are currently moving in a vertical direction. You can move it horizontally if you want a sliding door. You could make it rotate. You could make people or objects or cars or boats or anything fly in certain directions when you get in proximities, anything you like. You just need to adjust the settings to suit you and get them to work towards your narrative and what you're trying to achieve in the architecture. All right, the next little interactivity we want to look at is creating a three-dimensional soundscape so that when we're walking through our model, as we get closer to certain objects, certain sounds might start to play. So we can hear here, I've got this rushing water playing, and as I sit further away from that central area, it gets quieter. And then as I get further in, it gets louder. So having a soundscape of different sounds playing as we get closer to them or further away from them, they start to change, is going to change the overall immersion inside our scenes. So I've got this water playing here, which gets louder at the center point. I might have a sound that plays as this door goes upwards. I might make a certain character say words as I approach them, and as I'm walking past them, I can hear them muttering or something, whatever it might be. I can make sounds play in specific locations inside the model. So that's where we've got our water sound trigger at the moment. And if I was to click on that one, we'd see that there is this spherical radius coming out of it. So this is the starting point. So as I cross over this line here, I start the sound, and then this sound is its maximum point. So that's the source location, that's the maximum. So that's what those two sphere radiuses are. Let's go ahead and set up a second sound. What I'm going to do is I'm going to create some atmospheric drums, which get louder and louder as I get down towards the end of this particular level. And that kind of tells the character which direction they should be walking and where the excitement is coming from. All right, So first things first, let's navigate over to that area where we want the sound to be coming from. I want it just on this corner of the ledge over here. First thing we need to do is bring a sound in. So I've just downloaded some sounds from YouTube, and then what I did is chuck them into Adobe Media Encoder to convert them over to a waveform. Simple as. So they'll come in as MP3s usually if you download them from online. They just need to be at a WAV format. Really easy. Drag and drop in here, change the type to WAV, press play. No problems there. Once we've got that, we simply drag and drop it into our content library. So I've created a new sounds folder here. I'm going to bring in this percussion sounds that I've created there. Gives that a second to load into Unreal. Perfect, there it is. Now what I'm going to do is just put it here inside, and then I'm going to lift it up a little bit so that it's sitting in that spot. Perfect. Yeah, I'm happy with that. All right, now what we're going to do is we've got a few things to play around with. So the first thing we're going to do is we're going to come down to the attenuation and override the attenuation. So currently this is playing everywhere inside the model. So if we were to play this, it would just be playing everywhere. We don't want that. We want it to be proximity triggered. So if we click on override attenuation, that's going to give us its source. So that's the inner radius there. So we'll bring that in reasonably tight. It's about human height in there in terms of a source. And we can see how wide it's going out there. So we don't need to go past the start or end of our model. Our model kind of clips off there anyway. So what I'm going to do is just scrub this guy in a little bit. So that's just at the start of our model there. And then that way its softest point will be over there. Actually, I'm going to bring it even further. And that way, if I want to jump back to that level over there, it's going to stop playing the music before we get out to that level. And that increases the interactivity. So now I've got the start zone. That's the quietest zone on the inside. And that's my loudest zone there. And then the last thing I'm going to do is I'm going to double click inside here and just edit 2 of the settings. Looping I want on, because if I go in and out of that trigger moment, I want it to start again. I don't want to have to exit the game and start it up again in order for it to work. So I need to turn looping on. Then I'm going to scroll all the way down to our voice management. And this one here is restart. So basically what happens is, because we've got looping turned on, if we were to go outside of that trigger and then back in, it would start again from the beginning. That would be really annoying if you just happen to hover over the start area and it sounds like it's glitching because it keeps restarting. Instead, what we want is play when silent. So that means the track is always playing in the background. So if we happen to step out of the trigger and back into the trigger, it will play from where you left off. So if you left the trigger for 3 seconds and then came back, the song or the sound would be 3 seconds further in the distance, which obviously makes it more realistic, makes it sound natural. If you've got sound playing in an opera theater or something like that, you don't want to walk out of the room and walk back in and they've started the song again. It makes no sense. Click on save to finish that one, and then we're going to go ahead and play our game and see how we like it. All right, our drums are playing. We're inside there. Let's step out of the trigger. Aha, it stopped playing. Step back in. Great. So it's still playing. It's getting louder. Very cool. And it gets to the peak volume now, right where we are there. And it gets quieter as we step away. And so that is how we can add a whole lot of realism. Obviously, that's just one example, but you might have inside your model, you might have some assets that play sound like a running stream or trees blowing in the wind, or you might have even a stereo or a TV, or you might have projectors playing some sort of propaganda. And as we get closer to the projectors, the sound is there and we can hear it on screen, or whatever it might be. You can layer that sound in as an interactivity so that as we get closer to any object or get nearer, it's going to build onto that narrative. It's going to build on that experience and interactivity for the user. Now that is all for our blueprint basics we're going to have a look at, and of course there are plenty more for you to look at online on YouTube and elsewhere. Just wanted to talk about the fact that we are using a game engine, so we do have a world of opportunity in terms of interactivity. Something that you may be interested in is Niagara for Unreal Engine 5 allows you to do all sorts of fun stuff that we might like to add into our models. Things like a large crowd, which is procedural. So if you're walking around with the crowd, they would interact with you, i.e. move out of the way. You can walk with them and they would spawn depending on what you're doing. They follow your movement, that kind of interesting stuff. If you're walking through a crowded city or crowded building, You want people to cross the paths in front of you, even bump into you. You can do that kind of stuff. We can look at particles of water and foam or fire and lava, all sorts of stuff. There is plenty for you to play with in terms of particles and physics inside Unreal Engine. So while we don't necessarily have time to go through it here, I do just want to reference the fact that it is available to you. And there's plenty of videos out there on YouTube. If you just type in UE5 Niagara, UE5 physics, UE5 procedural growth, all of these different keywords are going to open up a world of opportunity for you. So if there is something out there that you and the team are trying to achieve, chuck it into YouTube, have a look. You never know. Someone may have already coded it all for you and you can drag and drop, or they may have put their steps into a video tutorial for you and you can just follow along. By all means, have a look. If there's something you're interested in and something that's really going to add to the architectural experience, that being the key, of course, have a look out there. See if there's something for you, see if there's something that works, and have a go. All right, that marks the end of video lecture 4. Well done on making it this far on your journey. So close. The next and final video, we're going to have a look at packaging it all together so that you can export your executable. We're also going to do something fun at the start of the video where we look at making a home screen or a start menu so that people can actually choose which level of your project, which level of your building, your architecture they want to start in. And they can then jump from level to level from your start menu if they want to, giving the client a whole new level of interactivity. Plenty more fun to come, but for now, happy interactive layering.